So who had any experience into having a catastrophic failure because of a scaling event in a cloud provider? Okay, yeah. So yeah, this is the story about actually finding balancing limits. It's a story about how we actually find the correct balance between our resources, whatever they are, money or people or even cloud resources, and actually defining what is the point where we're actually going to do something ourselves about fixing stuff. Just take one about the irony about limits and how you actually try to fix your own stuff, and it's kind of weird. Know yourself is the main point on this stuff. I'm going to show you a picture. This is a production, actually, picture we had in Delivery Hero. There is a problem hiding here. It's very, very, very distinct. We had to put a lot of people in on this to find out what was going on. And we actually hired a lot of people. We used machine learning and every other magic, and we came back with this. So the problem is there. This is where everything happened. I mean, yeah, it is there if you think it. Yeah. The problem was that, yeah, jokes aside, this is a real service in production. This is an image about a Redis node in a cluster. What happened here was that the value of a key was so big, but because of a deployment, that the throughput of the node actually reached the limit of what Amazon can do for us. Well, we had to go back and see what's going on. Obviously, we undeployed, we reverted the change. Then we had a decision to make, okay, what are we going to do next? Obviously, change the value size or maybe put some restrictions because developers love restrictions about what, but in everyone's minds, this was what's going to happen. We want this to happen, let's say, in a way we don't want to block. It's a valid choice to increase your budget. It's a valid choice to increase the amount of things that you have in a cluster. But you do have to have a quantifiable measure of when are you going to do it, when it makes sense. We have to drive this increase in size by some very clear data. And this is what we're going to talk about today. My name is Christos Skevis. I'm a principal engineer, system engineer at Delivery Hero. Also, yeah, olive oil producers because I come from Greece. I don't know if you noticed the accent. And today with Arne, we're going to talk to you about this problem we had.
Yeah, hi, I'm Arne. I'm a software engineer at Delivery Hero together with Christos. I'm a rare German in the Berlin tech scene, but I'm actually terrible at telling you anything about Berlin. Like all of my foreign colleagues ask me things like, what is this building? What is the history behind this? And I'm not very good at this because I'm not from Berlin originally. So just to say that. We work in Delivery Hero at the Foodora and Foodpanda platforms, which are like one of the main brands that Delivery Hero has. But there's others that you might have heard about, like Yemek Sepeti in Turkey, Pedidosya in South America, or Talabat in the MENA region. So the Delivery Hero itself is more like a holding for all of these brands. And we work in Foodora and Foodpanda, which is mainly active in the Asian market, actually, where we have a lot of growth right now. And the company is pretty big, as you can see. We have 80 nationalities in the office, not a lot of Germans, as I said. Active in 40 markets, 90,000 employees, like a lot of customer service and actually riders that deliver the food and so on. And we have 1,000 people here in Berlin, which is right around the corner, like 10 minutes walk, actually. Where we have mostly product and tech and marketing and legal and all these kind of things. Delivery Hero in total has around 2 million orders a day right now. Like Foodora, Foodpanda does a substantial amount of that. I cannot tell you exactly how much, but it's a substantial amount. And that is actually more than companies like Zalando do and so on. And of course, Zalando has a different basket size. It's a completely different business. But as tech people, we don't really care. We still have these orders, and they go through our system. We still have to handle them. So for us, we have to support this scale. And this is kind of what a typical day looks for us in terms of traffic. And because we do food delivery, it's very peaky, let's say. So we have the lunch peak, and then when we have a dinner peak, where everybody starts to order food, and then it goes down from there a lot. And at night, obviously, you don't you almost have no traffic in the end. And since I already said we have this kind of substantial growth right now in Asia, which can mean 10, 20% more traffic over the last Sunday, we were getting some kind of issues with our infrastructure in terms of scaling, because some of the legacy stuff was built 8 years ago or 7 years ago and is still PHP and was never meant for this kind of scale. So we had problems with downtimes, and we needed to have more confidence to be able to tell people, okay, if stakeholders ask us next weekend, we are going to start big marketing campaigns and we expect 20% more traffic. Can you handle it? Like, are you confident? We spend a lot of money. And at some point, we were not super confident about that. So we needed to come up with a strategy to solve this. And that was load testing, like automated load testing that runs periodically and gives us confidence about these things. So the main goals that we set for this whole project that we started like half a year ago was obviously to measure performance, but also to measure how high load impacts the user experience. So if you have very high load scenarios, maybe some dependencies fail, so you need to fall back. And if that is all working correctly, what kind of error rates you're getting and how kind of these peaks or the high load scenarios impact the user experience. But also to actually know when our production environment breaks. So it was a very important point for us to actually do this on production. And the tests run right now until we start to see failures, so we can stop them automatically based on some metrics. But we actually do this on production because we believe it's very hard to replicate our environment with all the dependencies, to just run load tests on it and then be actually certain that next Sunday will work without any issues. So we are big believers in doing this on production. And also to be able to access the impact of change. So we have big new releases, so that in 1 week you can see, okay, actually our performance got worse. So maybe this release introduced something that is not optimized enough yet. Maybe we need to go over that again. Yeah, these were the main goals that we set. And as I said, in the food delivery business, everything is good, everything is all fun and games until customers see something like this. And this is kind of when they are hungry, then when they are ordering food. So maybe they can't access a restaurant, maybe they can't complete their order, maybe the order doesn't get transferred to the restaurant, whatever. It's the worst time to have problems, but it always happens when we have the peaks, because that's when people order. So we have hangry customers, which is what we totally want to avoid, because it just is bad for the customer service teams. They have to kind of deal with all of this, sometimes days after big incidents. And it's also damaging for the brand, obviously. We have a lot of competitors, and people can just switch to another one, and then we lose them in the end. So we don't want that. So the question was, how do we implement these goals that we set? How do we do this load testing in a smart way, and how do we kind of go about this whole project? So at first, we looked at managed solutions. Like some of you may know Blazemeter or Load Impact, where you can kind of have a web interface, you can build your tests together, you can import files from JMeter and so on, and then run them also in a distributed cloud manner against your infrastructure, which is nice. And also, we also used this in the beginning, but we hit some limitations about first the amount of users that we wanted to run, because we wanted to run all services at the same time. The test, we call it the Big Bang test, which kind of hits everything. So whether we know where dependencies fail, when everything is under stress and so on. And we needed more flexibility also with exporting the logs. And these things were also getting quite pricey at some point, because then you have to go into the really big enterprise plans. And yeah, that's where things start to get really expensive. So we went back to square one, basically, and looked at the kind of tools that you can use for load testing. Some of you may know some of these, like WRK is a decade-old tool, which is very fast, can have very high throughput, but it's not very flexible in terms of scripting and user-friendly or developer-friendly, while on the other side you have Lowcost, which is a Python-based tool, which is very nice to use, very easy, and has good scripting capabilities, but on the other hand is a bit slow. So we evaluated some of these, and ended up with K6, which is kind of right in the middle, which has a very good balance of usability and speed. And also notice how all of these have like these warfare names like siege, artillery, Gatling, I don't know. So just that's something we did as well with our own tool in the end. So yeah, the choice is K6 because it's, as I said, modern, high performance, easy scripting through JavaScript, and has a lot of exports to InfluxDB, StatsD, etc. So it was very flexible because many teams have different or need different insights. So for us, it was important to kind of be very flexible in this regard. But K6 itself was not really enough because we wanted to run multiple instances at the same time. We want to kind of have a cluster of K6 running and then put a layer on top to automate it to run these jobs at certain time frames and report the results automatically back to developers of the certain teams and so on. So we built this layer on top of it, and we called it Haubitze. In the end, I thought, like, I kind of came up with this name, and then I thought maybe as a German guy, I should not kind of suggest the World War II weapon thing, but now it's too late. So, yeah, and now Christos will tell you a bit more about the technical side of things.
Yeah, thank you, Arne. Yeah, it looks, I know it's a war machine, but it looks very nice, right? So this is what we had in mind also. We wanted to build something very robust, very looking very friendly. So we started the first version of Haubitze, which looked more like this. So it's like, what does it mean though? Yeah, so it was like an AMI with the K6 spinning up as an automatic scaling group. You had to SSH to multiple machines. You had to do all these problems with human factors in place, forgetting stuff, doing stuff wrong, and all of this stuff were going very heavily wrong, but at least it worked, yeah. We successfully did one big bang test, and we found actually in the first run immediately problems in our systems that BlazeMeter didn't find, which is something very much promise, very good way to go on. So we made the second version, or maybe first version, version 2, which now we wanted to go into the cluster. We wanted to do, let's say, Kubernetes, because something we work on very much every day. We immediately get scalability out of the box. We get nodes, we get pods, we get a lot of stuff that we don't have to do manually. You get immediately EKS, with EKS that we currently are using, roles, and you can actually start doing all this authentication of user management of the EKS who has access to it. With Ingress, Nginx Ingress, and API gateways, you can now get also give access to developers. Maybe they want to develop their own tool about how to run the tests and how to connect with the Haubitze. We have volume management, for example, because a bigger part of how our design is to always make sure that the tests run at the latest version. And having this in place, I'm going to describe it a bit later as well. It's very important for us. And then also you have like custom and native resources like jobs, cron jobs. You can run everything every week. You can do automation stuff that you normally don't easily do. This is how it looks like right now. So we have very, it is rough, but it works. And there's an API behind it, obviously. This is a front end. We have built this so that developers can actually start using it more. We have more than 1,000 developers in one place, and you cannot really ask them, okay, use the API and do whatever you want with it. So, and also we need to start the adoption phase. And this is very critical as well, because if no one is using it, then no one is going to actually evolve it and make it work better. We have also the ability to connect with the K6 RESTful API. So because most likely you have not maybe used K6, when they start a test, it immediately creates a RESTful API that connects to the test. You can start, stop, or change configuration about users on the spot, or even pause, change configuration, and start again. And this way, having the pod logic behind it, you can expose this RESTful API and see it here as a play, stop, or pause button. And this is how kind of the architectural design looks like. So we have an Amazon S3 bucket, in which all the build processes are putting all the test files. The application owners are the ones that actually have to design and write the test files because they know best what the application can do. And then we have a Haubitze master module, which actually takes all these files and puts them in EFS volume. And then this CFS volume is being managed by Kubernetes cluster and as a PVC, so you can attach it to whichever pod you want. And it is designed and expected to be on every pod that runs. And the API basically is something that you can use in any case, in any different case that you might want to. And currently, I just show you the front end. So it's just taking this, parsing it, and using some Vue.js to show something that makes sense. I'm talking a bit about design now. The technical design is kind of now, I guess, more clear, but we have some interesting design choices as well. One of them already been mentioned by Arne, which is allowing to break the production. I mean, we don't want to break it, but if we shouldn't be able to break it, right? If you run a test, you should have this chaos monkey logic. You should be able to detect a problem and actually work around it. But apart from that, we always have to have the least privilege policy in place, meaning a person cannot really run a very huge test with malice in order to break the system intentionally. We should have some sanity checks on the test, so you can actually. There are some specifications, mainly to avoid being blocked by firewalling. So we have, for example, Cloudflare in front of our system, and it's going to maybe block the Haubitze cluster if it's going to attack it too hard. So some specifications of how the test looks like must be there in place to avoid this from happening. But OK, well, the technical part is done. Now it's, I mean, a manager will come over and tell you, OK, what's going to happen next Sunday? Are we going to be OK? I mean, I cannot give him the output of the pod itself, so I have to make sure that I can actually make a report out of this data. So apart from the managers, though, the tool is going to be used by developers, and we want to consider them as our customers in this case. It should be easy for you to get the data you need out of the run you've done, and you should be able to answer your stakeholder on planning meeting or whatever you have to do next in the next month in order for this application to not fail based on load. And what we do for that is basically we output every metric from K6 into JSON and then send them over to Datadog. And Datadog, with specific agent config, we can see immediately the dashboard of how it will look like when you are pushing the system 5 times over the traffic that you usually have. But even though we have reports in place, this would have been in the category of this extra one tool that you have. So you never use it. There was sometime Chris and Arne was fixing it, but no one was the case of how it looks like right now. So we want to incorporate it with other tools we have in place, so namely in Datadog and New Relic. So if you combine this into one project, one full entity that can produce outcome out of these 3 tools, you kind of won on this race, meaning that everyone will start using it and adopting more. And in order to make it more stabilized and more streamlined as a process, you have to streamline it and make some rules about how you're going to use it. We have in place now, for example, weekly tests that will be updated by every developer, and they get Slack notifications if they haven't done that. So we are going to push the mentality of load testing is here to stay. And load testing is here to make you being confident on your application in the future that will not fail. And if it fails, you know where and why. And with that, I leave you to one real use case of one application we had to improve a lot on. And by chance, I guess it's Arne's.
What does that mean?
No problem.
Yeah, so one use for the load test as an example is our service called Watson, which provides the restaurant list to customers. So customers first put in, I mean, you know this, put in your location, your address, and then you get a list of restaurants that deliver to you, and then you can filter it down, sort, and so on. And this is the entry point to every customer, basically. Everybody that hits our site goes there first. And it's a service that has the most traffic in our infrastructure, so around 3,000 requests per second at peak times. And stability is just of the highest priority in this case, because if this goes down, there's no way to fix it. Like the user cannot even see the restaurants. This is the worst possible outcome. So there we have to have this confidence that I talked about earlier to be able to say, next weekend on Sunday, when everybody's ordering lunch, we can handle this. So to do this, actually, since our API is mostly GET-based, so it's mostly GET requests, And we got just a snapshot of real traffic from Datadog, basically from our logs, and exported them. And that is then one would use on each of the K6 instances to replay and replay for all our Asian countries at the same time, so that we get an actual useful representation of the live traffic across all the countries and how it would be on peak times. So after we run this test, I would just want to show you like some kind of examples on Datadog, how we kind of analyze this data. So yeah, what you see here would be, for example, the Kubernetes kind of pod limits and requests. So this is kind of what we allocate for the pod to be used normally. And then you have some kind of buffer headroom where the pods can go into in case of high load situations and so on. But we always are aiming for keeping the pods beyond this and in the scope where they should operate. And this now looks very good from the load test perspective, but in the beginning we had a lot of instances where you saw this going up here a lot. Of course, the limits were also lower then. And then even hitting the ceiling where then you start to kind of starving the services for resources. And they cannot go as fast as they could. You get requests that have higher latency, you get more timeouts and so on. So from this, we were able to, across our services, of course, really fine-tune all these requests and limits for all the services and assess the scaling behavior and optimize it based on that. And we continue to do that all the time because it obviously can change whatever software changes you do. Scalability in general, the number of pods, for example, this line should, in ideal cases, go up as smooth as possible or linearly, but in this case, you see some bumps, which can mean that maybe some dependency at some point gets overloaded, so it gets slow, and the Watson application actually has to wait a bit, so it scales down because it has some free resources, or things that you can kind of derive from this. So there you can see kind of how the scaling behavior works. Or, for example, another thing that is kind of interesting to us is the latency in ingress, which is like the Kubernetes router. So if we see this latency increasing, it could tell us, okay, we have some request queuing on these services. There are more requests coming in that we can handle. Maybe some of the scaling settings are wrong, or maybe even ingress itself can kind of get overloaded and maybe needs more powerful pods or more pods and so on. So these are just some examples on how we use Datadog to kind of do this. We have complete dashboards of everything, but this is just to show you an example. Then future plans, we still want to automate a few things more, like to kind of, right now there's always an on-call person present when the test runs, because in case something goes wrong, or we have to stop early because unexpected things break, so we are not super good at detecting that automatically yet. So that is something that we want to improve on. Slack integration, so that the interface that you saw in the beginning that Christos showed, a similar way could be used via Slack, so developers can run their tests or schedule their tests through the command line, or get results back, get a link to the dashboard on Slack. And we also talked about open source plans. It's kind of, right now it's still kind of coupled to our infrastructures and Terraform and so on, so it's a bit tricky. But this is definitely something we are discussing, and might be in the future also. We're also hiring, by the way. I forgot that in the Delivery Hero slide. So if you want to do Kubernetes, Golang, and so on, very welcome to talk to us about that. Yeah, that's it from us. Thank you.